Right, as you can see, we've just bolted up those two coils now. They're at the top now, but they actually sit at the bottom when it's in the frame. So these are the two coils that have actually been replaced at some point in the past, or rewound should I say. Not by me, it's obviously in its previous life somewhere. But sadly, whoever did it last time, they actually failed to put, you notice there's this insulating sort of gasket material around the outside. They didn't have any of that in there. And what that meant was that the coil was actually able to move and spin and vibrate on the core. Which is obviously over time of using it, they've obviously had it moving and it's ripped all the wires off. So what we've done is attach new wires now so that that's obviously working, tests good, everything's working. We've just made up some new gaskets that sit in the end. That when you then tighten up the bolts, it then crushes everything back tight, so they can't move. So hopefully that should solve that problem. We've just had to replace the old flathead screws with some Allen tapered headed sort of bolts just to sort of tie they back in, because the old ones we had to sort of destroy getting out. Flathead screws and seized bolts are never good, even with an impact driver. So we're going to start putting this centre core back together on the brake now. So we've got some new bearings here, there's one for each side, two sort of lip seals to seal on the end, and then all the bits to go back together again. So we're going to start off by putting the bearings on the shaft and see how things are lining up here. Right, you can see the main shaft for now, which I've just pressed two new bearings onto and put back into the collars that basically secure it into that sort of cartridge in the middle. So it's obviously turning nice and freely now. Obviously there's no oil in those bearings yet, but there will be once we fill it up in the end. So the next step is going to be to actually install that into that cartridge. You're probably wondering how I'm going to do that with that one, but this one here is able to slide on and off easily because it's a roller bearing, not a ball bearing, which like that one is. That's so that it's fixed this end basically, and it can float on that bearing. You then shim either side of there and there to give you the exact clearances between the rotor and the stator plates. So that's how that works. So I'll get this into the cartridge and we'll come back to it then. Right, so that's the shaft back in. Both bearings are now in there. That's just the collar for the lip seal, which I need to remove. So those two flanges are up flush now. I did put just a thin bead of Heimler around the inside there. They are machine services, so I don't think anything would leak past anyway. But I've just put a small bead there just in case. So I've just fitted a new lip seal to these cover plates now. So what will happen now is there's a rubber gasket to sit between these two layers. That will then sit basically on top like that, hold the bearing in, secure that lip seal where it needs to be, and then these machined rings will sit down and seal against the lip seal, sorry. But I need to put the gasket in first. So that's the core, largely back together. So I probably should have explained before really actually what this bit is. I kind of just started stripping it down and made the assumption that it's obvious. But so this part here basically sits in the centre of the eddy brake. And for people that don't really realise what that is or what it's for, the eddy brake is basically the heart of the dyno for a setup like this. So that there is effectively what's putting a load, or you know, what's making the car work against to actually take a torque reading. Obviously you get the two main types of dyno that you see in use sort of around the world, generally either an inertia unit or a braked unit or a combination. So obviously with an inertia dyno you've effectively got what you see there, two rollers. Some of them will actually have a large flywheel connected to it, some don't. And basically they have no form of braking at all. It's just basically a car that accelerates the known sort of mass and inertia value of that roller. And by knowing the sort of moment of inertia and the speed of which it's accelerating with a speed sensor, you can then calculate how much power is being produced by the acceleration. So if we're just doing sort of basic power runs and that sort of thing, you can actually get away with just an inertia only dyno, although I'm not a huge fan of them, because unless you have a huge roller and huge flywheel, a lot of them I seem to notice don't put very much load on the car at all, which for big turbo diesels is not great. But the biggest problem with inertia dynos is basically when it comes down to actual tuning, because you've got no way of actually sort of holding a car back under any condition at you know, fixed RPM points, so you can actually work through the map or tweak the fuel pump or do whatever you're doing to get the car set up correctly. So that's when a brake dyno like this and like our old Clayton come in whereby you can then apply a load to the front roller, which is then able to hold the car back, so you can be wide open throttling the car at a set RPM, and this will hold it at that RPM without the car trying to run away. That then makes the dyno hugely more useful, and in my opinion is well worth doing. So obviously this dyno has got an eddy brake, so that's what that is. It works with the laws of eddy currents, which are basically sort of a complicated magnetic thing going on. So you've got the electromagnets on the poles are all either way round, and there's some eddy currents that form around those electromagnets, which then the rotors spinning then pass through those eddy currents, and they absorb the energy as heat into the rotors. It's kind of complicated, and I must admit I'm not 100% exactly how that law of physics occurs. A bit more research required. However, for all intents and the purpose, you effectively apply voltage to the coils, which then produces a load. Obviously the old dyno, if you watched the last series of videos I did, so the Clayton had what's called a water brake, so that's doing exactly the same job as the eddy brake. It's applying a load, it's just doing it differently. It's doing it with a friction of water inside the rotor and stator to produce a load, where this is doing it electrically. Advantage of this being that you've got infinite control and very quick responsive control. Basically you manually or with a computer can just immediately alter the input voltage, and the load is almost instantaneous to the roller. There isn't a delay of having to wait for water to fill or drain, etc. So that's basically why you're probably thinking, well, we seem to be spending a lot of time working on the eddy brake on this dyno, much like we spent a lot of time working on the water brakes in the last dyno. And that's largely because really these are the bits of the dyno that get all of the abuse. All of the power is absorbed into these units, so they have a lot of wear and tear and a hard life. And when you're buying cheap knackered dynos, they're generally the bits that are knackered that people haven't, don't want to, because to pay someone to fix them just costs so much money, so they go out and buy a new dyno. So yeah, we're going to be working on that. So as I was saying, we'll come back to the main core, which I've now got back together. So this sits in the middle of the eddy current brake. So you've got basically your electromagnet poles around the outside. The shaft sticking outside, a big stout, decent sized shaft. These Telma retarders are actually originally used in lorries for braking. So they actually sit in the centre of the chassis, and the prop shafts go right through it, one side to the other, so they're designed to take significant sort of through power. So I've just put 2 new bearings, one each side, 2 new lip seals, which then seals this unit. So this actual unit now fills up with oil. They're non-sealed bearings, so they live in oil to keep it lubricated. There's a fill port actually through this bolt hole, and a level port or a drain through the other bolt hole, which ties up some holes in the frame of the brake. So this is now ready to bolt back into the centre of the brake, and then we'll be sliding on the rotor on each side, and then bolting up, but paying particular attention to these shims. We've got hundreds of these little thin shims, which you basically put on each side to set the clearance between the rotor and touching the steel plates on the end of the poles. So that's quite important, but that'll be done once this is already bolted on. There, so you can see the cartridge is back in the brake now. So we've got a nice new rebearing and sealed unit on there that's ready to hang the stators on, the rotors on. But we're just going to clean up some vent tubes and the fill tube, and then we'll get some oil in there, make sure we haven't got any leaks. Okay, I'm just cleaning up the breather. This goes in the top of the unit, so that then goes down in, and it basically connects into that centre cartridge. There's a hole in one of the bolt holes, and it passes through. It's quite clever actually how they designed it. Right, so we got this back together now. So the next stage, we've got to wire up all these coils in series to run 192 volts each, 192 volt in total, so that's 12 volt per coil. But what's very important when you wire these is that you run the polarity correct, so that each bank of coils is north, south, north, south. So the way we're going to do this is with a compass, so 40p off eBay, because I couldn't find any. So what we've got now is just a little low amperage battery charger. So we turn the charger on, and well, it's white that way. It's a bit difficult to tell because that was pointing that way anyway. So if I now reverse the polarity of the connections, which is very difficult one-handed, you'll see that now the needle flings around and it goes the other way. And then if I quickly connect it, it goes that way. So you can see that changing the polarity is changing the way that it's pulling. So we've got to invert them now and go right the way around, connecting everything up, which is going to be great fun.
Yeah, considering that's a bank,
yeah,
and this side is a separate bank. That's not one whole separate.
No, there's 8 coils per side.
So both of those have to be the same.
Yeah.
Not north south. So it's north north, south south.